Hi everyone, welcome to Conveyor Meetup. Today we have Krishnan who will be presenting to us. I just have a couple announcements for us. So if you're not already on the conveyor.io email list and you want to make sure that keep getting invites to meetups on content about how to migrate Kubernetes, make sure you subscribe to updates at conveyor.io. Aside from that, we will be having our June planning session around the community and our tools. So if you want to have some input on what we should be working on, I'll be putting the Google form into the chat and you can just fill that out and you'll begin an invite. Well, and that's all I have for this week. So Krishnan, it's all yours.
Thank you. Thank you, Jonathan. Thank you all for joining, and thank you for this opportunity to present on this event. Let me share my screen. Okay. Is the screen okay, Jonathan?
All yes, good? You're all good to go.
Perfect. Thank you. Just a bit of introduction about me. I'm Krishnan Narayana Swamy. I started my career as a software developer, and right after the graduation, you're enthusiastic and with a few bunch of college mates. I founded a startup named Telesto based on open source Lucene search project back in 2008. And from then on, I have been associated with open source project, and I carry that passion for open source technologies, right? I have in the past, and I continue to help a lot of customers innovate and adopt open source technology, especially in the Kubernetes and the applications that run on top of Kubernetes. And that's exactly my role as well. I'm fortunate. I'm a specialist solutions architect for the ANZ region. I talk to customers within that region. I'm based out of Melbourne. I have my GitHub link there. Feel free to connect me on LinkedIn, explore my GitHub repository for some experimentations and demos in the Kubernetes space. Okay, so what are we planning to cover today? So basically, we're going to see how do we bake security into the dev and ops processes, right? And we are going to only focus on Kubernetes here, and also security on Kubernetes and the applications that run on Kubernetes. So back then, when I was a developer, right, I was working on code and also probably on the infrastructure, cloud native applications, legacy applications, monolith, microservices, and so on, right? But not even a single time I've given a thought like, okay, security has to be this way, right? Basically, all we do is we just develop code, we make sure it works, and then we containerize it and maybe push it and hope for the best to happen, right? But looking at from a security point of view, it probably wasn't the best way to do. So how do we bake security into our software life cycle? That's exactly what we will cover today. Kubernetes is awesome. It's a fantastic orchestration platform, and it's the backbone, right? But out of the box, in the open source version, it's got very little for, say, developers and probably from a security standpoint. It's got the backbone, it's got the extensions and the flexibility to customize, but nothing comes out of the box, right? So it's our responsibility to kind of have Kubernetes configured in the best way with all the security best practices, right? And we'll cover some of that today, and also we will see how Stackrox kind of bridges this gap. So introduction about Stackrox, it's a cloud-native platform, and recently Red Hat acquired StackRocks, and we have decided to open source the platform and the technology, and we are in the process of doing it. Please watch out StackRocks.io for any sort of updates on this space, right? We'll also cover some of the StackRocks architecture itself and how it kind of enables cloud-native security for Kubernetes clusters and the applications that run on them. I will try and demonstrate the product itself. There's a lot of things that come out of the box within the product and how it helps in, say, continuous security across your DevOps process and how it integrates within your CI/CD process. And the primary agenda, the goal is I'm trying to convey out of this session is that how do we shift left when it comes to security and continue? I mean, security is also a kind of a continuous process, like how you deploy or how you implement your applications, right? Now, why do we think container security is important, right? So just probably an introduction on what kind of attackers, what do they do with your containers, right? Now, common attacking could be just probably say cryptocurrency mining or some sort of, so basically all they attack is kind of abusing your compute resources. So try and get into your container, try and get some privileged access, and then go and probably abuse your compute resources. And if they're fortunate, probably an attacker can actually propagate to, say, other nodes in the cluster and even sometimes gain persistent access to some of your user code, compute, and most importantly, the data, right? Now, once you've got privileged access, then you could probably take data from some other containers as well. So you get into one single container and then maybe you move on to the next. And the worst part is the Kubernetes master kind of controls your cluster, right? Now, if an attacker could compromise that, he could potentially control your whole environment. I mean, he can have ability to take your application down, bring the whole cluster offline. And let's say if etcd, where you're storing all your cluster state and maybe your other configurations and your things like secrets, credentials. So now if he gets access to that, I mean, he could literally take all that and go and create a mimic of recreate your cluster somewhere else, right? So it is that kind of serious why container security is important. Now, let's discuss some kind of best practices, right, around Kubernetes security. Now, security has different levels, right? So from a cluster level, and then slowly moving up the ladder, your application, your network, and so on and so forth. So we will discuss a few of them here, but I have some references there, which are probably a great starting point to kind of go through most of it. Some of them could be recommendations are to keep your Kubernetes clusters up to date because there's a lot of patching, there's a lot of fixes for vulnerabilities coming across. So try and keep your Kubernetes clusters up to date. Make sure your network access is kind of firewalled correctly, right? And then the main entry point obviously is your Kubernetes API server. So try and kind of lock that down as much as possible, right? When I say lock that down, it could be probably through network, have access only through your VPC or VPN, or plus also the API, have the right AppBack controls, have the right user access for your Kubernetes API, and most importantly, lock the whole host itself down, right? And the other one could be have a matured CI/CD process to deploy applications. And what that means to security is that you would typically have one service account accessing your Kubernetes or API server in that case, right? So imagine an enterprise with large teams working on the same cluster, having consistent security practices and the consistent CI/CD processes have some sort of advantage as to you have to debug or fix or audit some of the access controls for only limited set of user or smaller number of service accounts, which is a great thing. So the key here is have a right RBAC controls in place for your cluster and your application access. And obviously work with, say, namespaces, segregate your workloads, the kind of from an application standpoint, right? So now it all starts with the image. Now, what kind of dependencies you have, what kind of packages, and most importantly, are you analyzing all your vulnerabilities and trying to find what already we know is bad, right? What kind of privileges that do you give for your containers in your host OS? So try to control, do not give root access, and so on, or restrict, or make your file system that the container access kind of read only. So these are best practices when it comes to deploying your container, right? And what privilege does a container have from an API server standpoint, right? What kind of secrets, sensitive data, how are you storing them, and then have some sort of, from a network level, have that firewall established, have some sort of a mutual TLS communication, have an encrypted communication across your parts and things like that. And there's one pretty good best practice is about labels and annotations, right? So labels and annotation play a key role when it comes to, say, Kubernetes or application that run on them, right? Because with labels and annotation, you can actually control your network firewalls in some cases, and there are a lot of controls and measures that you can take. It is very well kind of organized. So enforce that within your team to kind of have the right labels, have the right annotations, because that is very, very valuable when you are debugging for operations and so on. So some of the configuration best practices that I want to highlight is obviously have the Linux kind of secure your host OS. So there are a lot of Linux security modules, and especially one of them is SC Linux. Use those modules to kind of secure your host OS, right? And then have the right permissions, and probably do not allow SSH access inside your containers, especially at least in your prod namespace and things like that, right? And communication between pods, within the namespace, what kind of ingress traffic is coming in and egress traffic and so on and so on. But there are a lot of things to consider, but the main key message here is that remember that security is hard, right? So it's more of a marathon than a sprint. There's no such thing called a perfect security, and it is kind of evolving day by day, and things change day by day. So it's always monitoring it, kind of iterating it, and making sure you have the right tools and available for your team, right? So, and then you enable your developers, your security team, your operations with the right amount of data, processes, and tools. And by that way, you also integrate security within your build pipelines and your CI/CD processes. So it's a constant, continuous process here. Okay, again, throwing a buzzword here, so the DevSecOps, right? So but the idea here is embed your security early in your development process, right? So to prevent your security incidents and kind of enable continuous security in a more cloud native fashion, if it is probably on the Kubernetes and you're working on the microservices type of style of development. And the key part here is the feedback, right? So between the build, deploy, and your runtime phase. So a container running in production could kind of get into a vulnerability which came kind of released right now, and then you take that feedback, you identify that, you fix that in your build process, and then you take it through your security with all the scanning and vulnerability check again, and ensure it is certified, and then you deploy that new container into your cluster again. So that's feedback loop, and automated feedback loop if possible. That would be the best way to move forward, right? And the other thing is enabling, right? Like, for example, it's a culture change when you want to shift anything left, be it your dev process or security process and so on. So when it comes to, say, legacy, and there's probably some of the security, it was more around reaction to certain type of events, right, in the production. So I find something happening, and then I go and kill that process to enable that not to happen, and then I come and then find what caused the problem, do a root cause analysis, and then later on kind of fix. So probably that was more legacy process, I would call it, or more of a reactive. So more from a proactive process, you shift security left, you identify in your coding process itself, you identify in your build process itself, and try and avoid them going into production. So that's, and if they are in a much friendly manner that your developers and your team love, that's even better. So that's exactly what we will see today as well. Okay, just an introduction about StackRocks. So StackRocks, the platform itself is, it can run like in Kubernetes. It supports declarative style of probably configuring policies, and it does the same thing in the same cloud native way that you're used to in your Kubernetes space, right? And also the one thing I love about the product is that it can actually do everything within the Kubernetes context and pretty much integrates into the Kubernetes context and the APIs. So just to give you an example, right? So to kind of do an enforcement, it kind of integrates into the admission controller of the Kubernetes itself to kind of prevent that. So now prevent that an application from deploying and so on. So this way, it is much better when the product evolves, when Kubernetes evolves, I mean, the open source platform or the product also can evolve, right? So that's a pretty key thing. Now, from a benefits standpoint of being cloud native Kubernetes security, right? So since it is running within Kubernetes and also it kind of does everything in the same Kubernetes fashion, it has more visibility across the platform. So that kind of helps to eliminate blind spots. And then it can easily detect your threats that are unique for Kubernetes. So that's another benefit I see that. And time to implement anything like, and kind of the learning cost for your team. So you're already deploying in Kubernetes, you're already working in Kubernetes. So onboarding StackRocks into your team's processes, it's really, really fast. Like I could set up the application in say 15 minutes and gives you a nice little view of the whole security. So so you can do that as well. So now, and it remediates in the Kubernetes fashion. So like I mentioned, I gave you an example of the enforcement policy, right? So it remediates everything in the Kubernetes way. Let's say it has to fix something. It doesn't kill the part straight away as a separate process sitting outside, but rather it tells Kubernetes deployment spec to go and say, hey, you need to make this change. So Kubernetes is well aware of how StackRocks is kind of remediating a problem within Kubernetes. That's another key advantage that I see. And obviously, there's no operations kind of conflicts because of that. So there's no inconsistent configurations because you are actually working with one source of truth within the Kubernetes. And the key thing is the ability for StackRocks to bring security into all different phases, right? So the build phase, the deploy phase, and run phase. So we will see some of the use cases around each of them later in the slides. It supports all Kubernetes, can run anywhere, public cloud, private cloud, hybrid cloud, can even be deployed as, say, disconnected installs on-prem. And it is very highly flexible and kind of integrates with most of your platforms that you might be using today. So, for example, can integrate with some of the CI/CD tools like, say, Jenkins, GitHub, Circle CI, and maybe Tekton, and so on and so forth, right? So it's flexible in the sense like, so for example, for image scanning, so in your organization, if you're already using Tenable or Claire or Anchor, you can bring that and probably ship that data to StackRocks, and StackRocks can work on that vulnerability scanning on top of that particular data. So you can plug and play things that you need, same as registries. So bring your own registries. It integrates with some of the most common ones. From a notification, so that's pretty key, right? So the DevOps notification functionality that StackRocks brings, like you can integrate that within your, say, Jira. Hey, I use Jira. I can for my ticketing system. So I find something in my build process which is not good. I go and create a ticket in Jira. So through a notification from StackRocks, hey, my service operation team uses Slack, and I send a message on Slack for something that's not right in my runtime within the clusters. Hey, through my build process, I found a vulnerability in I broke the build. Send a Slack notification to my development team, and so on and so forth. From a SCCM perspective, we can integrate into, say, Splunk, Sumo Logic. Actually, both of them use StackRocks within their organization as well. And we have special plugins to kind of integrate with them. It integrates with some of the cloud security tools like, say, AWS Security Hub and Cloud Security Command Center. And if you don't find anything, you have a syslog protocol and webhooks to kind of integrate with some of your other tools as well. From an architecture perspective, so StackRocks has something called a Central. That's where it has the UI container running, and then you have some sort of an API server for interaction with StackRocks. It has got an optional scanner. A scanner is typically used for the vulnerability scanning of all the images. So it runs as a cube horizontal part scaler, part autoscaler in the same cluster as the Central. It scans the image layers. It takes up API calls. It kind of retrieves and updates your CVE data from StackRocks.io or from another central source, and so on and so forth. And the main kind of additional thing that the Central does is it kind of performs that policy evaluation. So it has got the core policy engine, and it can manage multiple clusters. So Central runs, typically you deploy Central in one of your clusters, and if you have multiple Kubernetes clusters, you can then deploy. So those components that you see there in the slide, like, say, sensor, admission controllers, collectors, they all run within the clusters that you want to manage, and they report data. They collect data and report data into Central. So all these communication happens through mutual TLS. So everything is secure and encrypted within so the platform. So sensor is the one which kind of discovers your namespaces, your running services, your network policies, your secrets, and so on. And it also does an offline sort of a rule processing, because if you have some sort of a disconnection, and if there needs to be some sort of decision that needs to be taken, so you think of them like an edge decision-making point as well. So it has got a small level of rule processing done at the sensor level as well. Collector runs as a daemon set in your nodes, and it's the sys level. It runs as a container on each host, and it kind of inserts a kernel module, or you can use the eBPF, and then it kind of gets all the node level operations, and it kind of collects all the runtime data, and then helps in kind of runtime detection, right, for any sort of anomalies. And the admission controller is the one key for enforcement. So it integrates within the kube admission controller to kind of approve or deny some sort of API action. So to give you an example, let's say you're going to deploy a pod, and then that request StackRocks intercepts and evaluates, and then it passes on to the kind of kube administration controller, and then it can say, hey, I do not approve this, and then so the kube rejects that request, and then the deployment is kind of not happening. So it's all done within the cluster in the Kubernetes way, as it would expect. Some of the use cases, right? So for Kubernetes Cloud Native Security, some of them out of the box, some of the Kubernetes distributions already provide, for example, OKD, which is the upstream, right, open source version of OpenShift, kind of brings in most of the cluster level security. So for example, the core components of Linux kernel, your C groups, and then it has got namespaces on your Linux, and then the SE Linux module. All these kind of protects your core OS, right? And then it uses cryo container runtime, which is great because it's got a smaller footprint and which can attack kind of it can give you a reduced attack surface if you have got a smaller. And then a lot of other platform as a service things that you can bring on top on OpenShift is like the IAM, your RBAC controls, your security context constraints, where that allows administrators to kind of controls permission for your pods and things like that. Additionally, you have something called a compliance operator that can check your state of the cluster and kind of provide a overview or gaps and things like that. And it can help you to do secrets management. And then it has got some file integrity operator which you can install, which probably helps you to check if there is any sort of file access problems or issues. And it's got volume encryption within. So all these comes out of the box, but most of them are cluster level, right? Now, StackRocks kind of elevates to the next level. It brings in application into the context, and it gives you the ability to create and customize policies for your own organizations from the user interface, and it gives you a much better visibility across the state of security across your Kubernetes cluster. So from a multi-cluster standpoint as well, pretty great to enforce that policies. And the ability to kind of respond to those events through alerts and notifications, and also kind of take actions or automate those actions and remediate those problems and things like that. So all this on top of that, from a build perspective, so StackRocks provides you with the vulnerability scanning and management, your CI/CD integrations, for example, through CIs and other compliance checks. It can do registry integration like we spoke, and it kind of can block deployments from not happening because of some sort of a build is failing because of some sort of a vulnerability check. From a deploy security, it can help you to kind of declaratively create policies across and enforce them in all the clusters that you're managing. It can give you a kind of a risk profiling for your whole cluster or for the namespaces and so on. Compliance benchmarks, so they are pretty great. I can show you in the demo. That can be kind of exported and passed on to your auditors and for all those. So the security team typically love these type of benchmark reports. Gives you kind of a good RBAC analysis for your Kubernetes cluster. Network policy, so you can generate network policies and enforce them through StackRocks across your clusters. And then it's kind of with a single pane of glass for security, if you like. And service configurations, admission controls, Kubernetes events, and runtime security. It can probably detect some sort of a intrusion, or it can do some sort of a behavioral analysis. From a network, it can kind of scan or look for network traffic and kind of create a baseline. So which pod is talking to which pod? Is the pod talking to an external traffic? Where is the network flow and so on? So it has got a nice little user interface to see all that visualization, and you can generate some sort of network policy and enforce it right there to all your clusters and things like that. So probably we can go to the demo, but before that, I just wanted to introduce linter. So this is more of a StackRocks getting shifted left, right? So it's open source. What it does, it kind of checks all your Kubernetes YAML files, checks all your deployment specs, your Helm charts, and it can find some sort of errors. So it can be integrated as a sort of a GitHub action or within your CI pipeline, and it can integrate with any sort of CI tool as well. So it's like a single command, and these right now there is 16 default checks that I saw, but there's a lot more you can do. So what you're trying to do is you're enforcing when the developer is actually coding it, right? So you're saying, hey, this particular pod spec that you have created does not say you should probably only read only file system access, right? So, or hey, this does not apply any sort of memory limits or CPU limits here. So please do fix that. So all this can be kind of brought into. And yeah, as I mentioned before, so please do go to stackrocks.io, join our Slack channel, participate and contribute, and thank you. So maybe I'll go to the demo right now. Maybe I need to just share and share again, just to get the right screen. Okay. Are you seeing OpenShift console?
Yes,
Jonathan?
Krishnan, you're good to go.
Okay, thank you. Perfect. Let me probably go to the. Let me show you guys what I've deployed. So I've got StackRocks deployed within my OpenShift cluster. So these are the components that we saw, right? So it's running both for my central, which is my UI component, which we'll see in a bit, and there are collectors, and so what I'm doing here is I'm monitoring my own cluster. So that's what exactly is, and then I have a few other small microservices that I have deployed, which typically are the bad guys. So they're going to help my demo to kind of show you guys some sort of vulnerabilities and things like that. So this is exactly how the console looks like. So just give me a sec. Yeah. So this is where typically you will land in a dashboard. You're seeing that Red Hat Advanced Cluster Security. So this is after our acquisition. This is probably our rebranded one, but soon, probably in a month or 2 months, you will see an open source version as well. That user interface might be slightly different. Don't blame me for that, but this is probably the current version as of today, right? Now, so the console shows you kind of a compliance report through various number of different compliance, like say PCCA, DAS, HIPAA, and CIS Docker, CIS Kubernetes, and so on and so forth. So the number of checks which comes out of the box, and then it kind of generates. So you can also create your own profiles. You can also have your own controls embedded into the platform when it comes to compliance as well. And the dashboard kind of summarizes like a single pane of glass that shows you all the violations, what is the risky deployments out there that I have got, who are the bad guys, and so on. And DevOps best practices, and some of them like security best practices. So these are kind of context that you can bring in, right? So when you create a policy, you can say, this is my, we will see that in the policy demo, but this is my kind of the context where I'm going to create this, and then you can generate reports and dashboards for them as well. So now the best part, or first thing I would like to probably kind of show is all the policies that probably the system has, right? So there's a number of policies, about 76 come out of the box, but again, you can create your own policy. So for example, let's, so this is probably a cryptocurrency mining process execution. Let's take up this one, for example. So this one tells us for a vulnerability scanning check, right? So it's going to check, this policy is going to be applied for when you have a CVSS score, if you don't have. So with this, now if we go into and say, for example, edit this policy, you can assign severities to it. And the best part is you can say what kind of life cycle stages this policy applies to. So does it apply to build? Does it apply to deploy or runtime? So this is typically for your build process. So you want to say in your CI/CD process, hey, if this particular package that I'm using does not pass my or attain my CVS score that I need, then probably do not allow it to kind of even process the build or even deploy it. So in both stages, you're kind of applying to it. And the best part is it allows you to kind of put the remediation, right? So it says, this is exactly what you need to do to fix it. And it gives a nice little rationale as opposed to now here in the remediation, you can even go and say some sort of a Docker command or, hey, this is the Java package that you need to change in your this particular form file to kind of fix it. Or this is the Docker command you need to put in your Docker file. So you give that context back to the developers in the way they want. And that's one of the key things, right? So they're happy to fix it. And then you have a different level of notifications. So right now, I don't have any integrations configured on this cluster, but typically you can send some sort of notifications like we saw, like Slack notification or Jira and things like that. So what happens when there is a violation happens for this particular policy? You can restrict scope or exclude scope for in your cluster with different namespaces. You can exclude or restrict some of the cluster or namespaces within the cluster here. And the best is when you create new policies in the UI, there's a nice little user interface to kind of drag and drop. So you can say, hey, I want to kind of look for parts which kind of exposed ports. So to block them or do this, or you can take those. I mean, you can say these are the actions I want to take, or just report and then probably I will kind of take action on them manually and so on. So everything like from a Kubernetes access are all segregated. So all this you kind of drag and drop. You have conditions to create your policies, and it's pretty flexible as well. And then it kind of checks the number of different. It shows you a view of what are all the different namespaces that it applies to and things. This is the best part of enforcement. So now you say, where you want to enforce them. You can switch on and off. So what this really means is now with this build, this will make the build fail because I have said I want to enforce. So fail the build if this particular policy does not pass. And then I have said deploy as off, which means, okay, that's fine. I'm going to still kind of allow just for our demo purpose, but typically it gives you that ability to kind of enforce how we want to enforce the policy and so on and so forth. Other things I wanted to show was more around, so for example here, you can even do some sort of cluster level things like, for example, you can say, I need an annotation, like email annotation, definitely. So do not allow any kind of, create any kind of Kubernetes artifact or a resource without in this namespace without this particular annotation and so on. So these are sort of best practices you're enforcing into your team through the policy. And from a violation standpoint, so this is where you get to see all the violations which are there, kind of categorized with severities. So for example, if I go into one of my microservices, for example, let me go into payments. Let's say I go into the visa processor, and let's say I go into the terminal, kind of see, and this should ideally trigger some sort of a violation to within the cluster, saying that there has been some sort of somebody logged into terminal. So it's typically your SSH access from a visa processor namespace and so on. Now, from a vulnerability management, so if typically the inbuilt scanner of StackRocks itself kind of gives you a lot better functionality, but if you have other vulnerability scanners, you can integrate with them, typically have all this, and it gives a nice little view of what are the vulnerabilities that I can actually fix them, right? And you can then say, hey, these are fixable, ask your team to kind of go and fix them. and then you can, if there is something new that has come, you can come and typically search for a kind of a CVE that has come up, and then you can see what are the different deployments it has affected and what kind of impact I have within my environment due to that, and so on and so forth. And from a configuration management, again, through policy violations, it can tell you what kind of admin roles, what kind of RBAC, and what are the different policies that constitute into configuration management, what has failed, and so on. So it looks at, say, certificates, any compromised secrets, and so on and so forth. And you have RBAC visibility and configuration as well. And the other key thing I wanted to show is about the integration of the platform itself. So it can integrate into a number of different registries and scanners, some of the integrations that we saw. And then, so these backup integrations, so they typically, so internally, StackRocks uses RocksDB, which is a key value store. So you can probably back up and restore that particular state. It's typically how you would do on a normal cloud native application. A cluster init bundle is typically great for automation. So when you onboard new clusters, so for example, if I go into the clusters, so right now I have one cluster which is onboarded for monitoring within StackRocks. So, but if I want to onboard multiple clusters, so you can kind of add a new cluster here and generate a small cluster init bundle, and then you that's a nice little YAML file that comes in, and then you go to the other cluster. You then say, I want to do installation of StackRocks in that cluster and pass in the cluster init bundle, and this will automatically connect to this central to kind of start to ship data to the this kind of cluster. So it helps in onboarding clusters. It was pretty easy. And we have a nice documentation. It's all available open source. So if you go to StackRocks, help.stackrocks.com, you get nice installation help and whatever help you need to configure it. Right now, you have Helm charts to kind of onboard StackRocks, but we are in the process of making Kubernetes operator as well. From a network security perspective, so this is the nice kind of a network graph that StackRocks builds for the applications and deployments running. So these big circles are my namespaces, and these are my deployments, small ones which are there. So if I click, say, one of them, it kind of tells me, hey, there is a anomalous network flow. So, hey, this particular application is not supposed to talk to my jump host, or there's some sort of a illegal network traffic going on. So how StackRocks finds this is that typically it creates a baseline. So for example, the Visa processor talking to gateway is probably an approved traffic, and that normally happens, right? So that's probably my baseline. But suddenly I see a traffic which is which StackRocks has not seen, and then it kind of adds it into an anomalous flow. And then, as an administrator, you can then come and decide whether to add to baseline or kind of take action on this one. And then you get to see all the different details, what kind of secrets, volumes, and things like that, what kind of network policies you have applied, and so on. And then the network policy simulator can actually help to generate network policies, and then you can actually apply them in your cluster, and so on. Right? Now, that's probably the overview of the user interface. Now, let me show you how it looks when you integrate into your kind of a pipeline. So what I've got is a small, simple Tecton pipeline within OpenShift. So one is for deployment and one is for the build itself. Right? So this pipeline, what it is doing is a simple one, just does a image scan and a check to find if there is any kind of vulnerability or not. So I've got a cluster task. Is probably yeah. So this cluster task is what is getting executed within my pipeline. I just wanted to show. Yeah. So this is doing a kind of a ROC-CTL image scan. So ROC-CTL is the CLI for StackRocks, and it does a bunch of commands similar to say kubectl. You can kind of use that within your CI/CD. So it's a easy way to kind of onboard to any. So if you go to say Azure DevOps pipeline, you can then probably just download and install ROC-CTL on your agent, and then probably just execute commands and integrate StackRocks within your pipeline very easily. And then if I go into the pipeline itself, so for example, if I see one of my failed pipeline, this is exactly how it looks. So it clearly tells you for the developer in his context, for example, ensure these images are scanned and it failed a policy which has this one, which is the policy, and what is the rationale behind it, what kind of remediation you need to take. And also it gives a nice little view for developers as to what other things is also failing. So also fix all of these and kind of stuff. So this is the kind of view you get for the developers themselves, and it's easy for them to fix and then rebuild. So in this case, if you remember, we had an enforcement on for our build process. So it's right now failing the pipeline check. But from a deployment, we actually had it to be allowed. So this is a simple one which has a YAML, and then it kind of, even though there are probably a few vulnerabilities, it's not achieving CVSS of 7, but still we have not enforced it. So it kind of deployed it into the cluster. And probably I just wanted to highlight on the kube linter checks. So there are these are the number of different checks, like say dangling service, default service account. So all these checks happen in your YAML files. So please do have a look at kube linter. And then StackRocks has also has some sort of contributions, for example, examples as to how do you integrate with Azure DevOps, GitHub, GitLab, Tekton. Argo CD, Google Functions, and Circle CI, and so on. And also there are a few other examples and scripts on some of the configurations you could do. Please do check out StackRocks/contributions as well. And I think that's it I have got. Over to you, Jonathan. And if there are any questions, happy to answer them.
Yeah, Krishnan. So I think what everyone probably experiences is the same as me. As soon as I had a question, you started answering it. So I think you did really well on this, because I actually don't see any questions on here. An interesting part was that, a little poll we ran where we asked like Kubernetes-native security, whether people are running it now. Out of 6 votes, 83% said that no, they have applications in Kubernetes, but they're not using Kubernetes-native security. My question to you is this something that you're seeing a lot of, like right now?
Yes, definitely. And believe me, internally as well, and I have been getting so many interest with a number of different customers, especially who are on their Kubernetes journey and really looking for some sort of a Kubernetes native security platform, and StackRocks really fits well there. So please do explore, and it has generated a huge amount of interest.
And is this something that you tend to find that people want? When do people tend to look more for Kubernetes native security? Like, are they on the Kubernetes for a while, and then they come across an issue that makes them, look more into this, or like, yeah, what have you found?
Yes, so people who are already in the Kubernetes journey, typically security is kind of an afterthought, right? So I mean, including me, including everybody. So, so it's typically what we find is that they tend to use it and then they realize, oh, okay, there's probably a much better way to do it, or this is probably a right way to do it, and then they go and probably fix it. But like I mentioned, security is kind of also like a marathon than a sprint, right? So it is the continuous security, and then you have the right tools and the processes and the culture within your organization to enable that. And probably that's the way forward to kind of achieve that continuous security.
Yeah, that makes sense. And I actually do have a question here. So Jason is asking, does linter have any rules for operators yet?
Does linter have any? Okay, if I read that question correctly, does it support checks for the operators as well? Is that correct? Or
That's what I think he's asking. Yes.
okay. No, so linter is predominantly for your YAML files and YAML charts. Yeah. So it doesn't have any support for operator as of now.
All right, and I have another one. RHACS. I'm assuming that's StackRock for the new version of it.
That's right.
Does it use compliance operator for the compliance measurement, or can it be integrated with something?
No, so it does not use the compliance operator. So it has got its own compliance check and the modules built in. But it does kind of get the vulnerabilities and its CVEs are all updated from kind of central location, which both your compliance operator and kind of StackRocks do. And which one do we use and when do we use and what kind of overlap? So again, compliance operator, you enable them per cluster level, and then it generates a nice little report. You can see them in HTML format to kind of, or you can take that report and say, this is all my CIS Kubernetes compliance has passed, or CIS Docker has worked, and so on. But I feel like Stackrox kind of enables across multiple clusters, and it can enforce multiple different profiles, ability to create new profiles and things like that. So more user-friendly is what I feel when it comes to Stackrox.
Okay. All right. And looks like those are all the questions we have. Krishnan, thank you so much. You've provided your information if people want to get in touch with you. For everyone else, I put the link in the survey. I put the survey link in the chat. So please fill that out. That helps the presenter know, what he did well. And let's see, I got something in chat. So I actually have more questions. This is good.
Okay.
Naoya, so your question did get answered. And in the meantime, is ACS available on managed OCP cluster?
No, not right now.
Not right
but
now.
there is a program called OCP Plus, which we are kind of releasing, where we are kind of bundling ACS, ACM, and all that. But yeah, watch out for that space. But there's no managed offering as of yet.
Okay, so be on the lookout. All right, guys. Well, thank you so much for attending, and we'll see you next time. Ciao.